Ladies and gentlemen, welcome back to another live stream. So in this live stream, we're going to continue on our game engine that we started, or render that we started in the previous stream. So like it took us like around 5 hours and a half or something like that to get a Vulkan triangle, though using like with multi-window rendering and so on. That was very interesting. So hello Loop Preliminary, welcome to the live stream. I forgot to actually share the stream in my Discord. Everyone live, and there you go. So I guess welcome Loop Preliminary. Let's pop out the chat and let's get started. So I fixed one issue we had before with in-flight fences. It was a very simple fix, though it took me quite a while to find. In fact, hold on, let's do this. Yeah, and then let's grab this like that, and there you go. Okay, so let's continue on our business. So I'm gonna first of all show you the changes that I've done from the previous stream. So let me check. Okay, so first of all, I fixed in-flight frames flickering. So there we go. So right now, as you can see, it's actually two in-flight frames. So I don't think I have actually explained well what in-flight frames are, because I was very, like at the end of the stream, I was kind of just trying to finish the triangle as fast as possible. So in-flight frames are basically a way that we can allow the CPU to prepare the next frames. So let's say while the GPU is working on one frame, the CPU could be preparing the second frame instead of waiting for the GPU to finish on that frame, right? So basically, if we have two in-flight frames here, we have one extra frame that the CPU could prepare for the GPU, basically. And that's basically it, really. But anyways, so the fix was pretty simple because we were using AI to generate a lot of the code. And I'm glad we're using AI because, well, it really helped me cut down on a lot of boilerplate code there. But the problem with AI is that you'll have to always be careful what it's actually writing. So like you have to verify what it actually generated afterward, especially if you're doing something out of the ordinary, like, and that is not common, or that is new, or that is cutting edge, which is the case with, like, let's say dynamic rendering extension that we're using for Vulkan and so on. But anyways, so let's see, where is the fix? Okay, so the fix was here, right? So this was generated by AI mostly. So we have self-swap chains views, and here we're actually getting self.frameIndex. So instead of using the image index that we got of the swap chain, right, we're actually using the frame index, which is incorrect, right? So the frame index should only be used for the actual frame resources, right? The in-flight frame resources, which is the command buffers, the, what is it called? And the synchronization resources, like the fences and the semaphores, right? But for the swap chain views and images, we should actually use the image index that we got. So the AI actually thought that it was a good idea to use the frame index, and so we had that flickering problem where we have one frame that is correctly rendered and the other is black or whatever. So this is the easy fix of that. That's the first thing. Second thing is that somehow I wasn't transitioning the image in the correct order, but it still worked somehow. I'm not sure how, but basically, where is it? Okay, so basically, hold on. Right, so I'm actually transitioning the image, right, from the indefined image state to the renderable image state, right? But then I'm immediately transitioning it again to the presentable image state. Then I start rendering, which is of course incorrect. I want to like take the swap chain image, transition it to the renderable image state. Then I should start rendering. Then later on I should transition, when I'm like finished rendering, then I should transition it to the present image state. Here I was doing both at the same time, which is incorrect. So what I've done, I actually removed it from here. So I only transition it to renderable image state. Then I start begin rendering, right? So once I'm done with the rendering, as you can see here, then I actually transition the image state to the present image state. So that's the other change that I've done in this commit. The other one is this guy right here. This one didn't really fix, I mean, it may have fixed, but like this is irrelevant to the flickering thing, I believe. But anyway, so the problem that we have here is that this is the renderer, right? Yeah, this is the renderer file, right? So when we get a resize event from the window in system from winit, what we actually were doing is that we immediately resize the swap chain, which may not be a good idea because the swap chain could be busy at that point, right? So instead of that, I want to actually control when we allow the swap chain to resize. So what I'm doing, instead of immediately resizing the swap chain, I just mark it as dirty. So we can actually, in the next frame, once we're sure that the swap chain isn't busy, we actually resize it. So that's one thing. What else? Yeah, so that's pretty much it. For this commit, there was another commit that I've added, I think. Let's see. Fix crash on window having a render area of 0. So after I fixed this error, I found another bug, which is that the window, like the app location would crash when you resize the window to be zero area, right? Either width equals 0 or height equals 0. So how did I fix that? Well, let's see. So what are the changes that I've done? Okay. No, not this file, I think, or is it? Oh, there you go. Okay, cool. So I have added these lines right here. So I said if self.swapChain extends, so this is in the render function, right? After I checked if the swap chain is dirty, and then I resized it, what I've done is I check for the width if it's equal to 0 and the height equal to 0. If that's the case, then I skip the rendering, okay? Though the order is very important here. The order is very important. Now, beforehand, I was actually doing these reset fences and resetting the command buffers before checking if the swap chain is dirty and resizing it, which is not great, right? Because I could quit here, right? Like basically, if the swap chain extent is 0 area, what would happen is that we would skip the rendering part, and so we wouldn't do this process here that would allow the fence to signal, you know, which gonna basically hang the application once we come to the wait for fences, because there's nothing that would actually signal it because we actually have resetted the fence. It's no longer in the signaled state. So it would basically hang forever after the fact, right? Which is not great. So what I've done is that, first of all, I check if the swap chain is dirty. If it is dirty, then right here we can actually resize the swap chain. After, of course, we wait for the fences that would basically signal for us that, or mark for us the fact that the swap chain is no longer busy, you know, or at least this frame is no longer busy. All right, and then what I've done is that after we have checked for the swap chain extent, we're sure that we're gonna render in this render call. Then I actually go ahead and reset the stuff. I reset the fences and then I reset the command buffer. Though if it actually have found that the render area is 0, what's gonna happen is that we're gonna go out of the render function. So we're gonna ignore this code or this process. And what's gonna happen is that it would find still that the in-flight fence is still signaled because we haven't resetted it just yet. Though that wasn't the case beforehand. So that's one thing. The other thing is this is just a little performance bonus, possibly, I guess. So in the begin command buffer, since we're actually going to or hold on, what the heck? Hold on, what's happening here? Da, da, da. So here we have begin command buffer. Yeah, so here this is just a little organizational thing, nothing fancy. I just, the states was kind of not allowing me to see through the actual order of the commands, so I just declared the states first here, and then I started begin the command buffer here. And yeah, this is the bonus that I talked about, is beforehand, when I began the command buffer, I wasn't passing any flags, but right now I'm actually passing this one-time submit because we're gonna pass the command buffer one time, then we're gonna actually reset it. So there's just a little performance bonus there. Is there anything else that I missed of the changes? Yeah, that's pretty much all the changes I've done so far, and the application is working perfectly with 2 in-flight frames right now, which is great. So yeah, pretty much. Okay, let me show you. So I'm gonna run the application right now. And there you go. We have 2 windows with the triangle, and it doesn't crash when it's render area 0, and resizing is very freaking smooth. So that's pretty great. Okay, cool. And let's actually try to compile it in release mode and try it in render doc and see how much FPS we're getting. So cargo r -- release, and then I'm gonna look for the release folder here, and let's see how much FPS we're getting with this configuration so far. Okay, my CPU is getting exploded right now. Is the quality of the stream fine? Please let me know. We got the mic on, camera on, no dropped frames. Seems perfect to me. And there you go. Oh my god. It's even smoother now. Maybe it's just an illusion, I don't know. Let's see how much FPS we're getting here. Debug release. And I think we have this in mailbox, right? Make sure it's in mailbox. Otherwise, if it was in FIFO, then it would just sync with the monitor, which is gonna cap the FPS to the monitor, right? So basically VSync. Mailbox is also VSync, but it doesn't cap the frame rate. Right, so let's go to the swap chain, right? Where is the swap chain? There you go. And where is the present mode? Yeah, I'm setting it to mailbox. Though some GPUs doesn't have mailbox, so we'll have to check that for that later on. But anyways, so let me right now just copy the release mode path, absolute path. Then I'm gonna go to render doc, executable path, launch, and let's go. Alrighty. and we get around 2000 FPS. That's interesting. 3000 FPS. And if I want to change to this, cycle to this window, I could say F11. There you go. And now it's showing me this Windows stats. Though if I made it smaller, of course the FPS drop when you're resizing. That's to be expected. What if it's full screen? How much FPS we're getting there? Still 2000. Okay, that's pretty crazy. Let's though do a capture and see what we got there. Oh, by the way, hold on a second. Is the Vulkan configurator is on, which may be slowing things down a bit though. Let me make it off and let's try to launch again actually. Launch? No. Oh boy. So the validation is off right now. And well, what? How the heck it's less FPS now? What? That's strange. I don't know how it anyways, let's just go back to, yeah, let's just get a frame right now. Hold on, let me capture a frame and let's get it. So these are the commands that we have. Ooh, why we have kind of two frames here somehow? Oh yeah, because we have two in-flight frames right now. Yeah, pretty much. So that's cool. We have VKQ submit, then we have one color pass. VKQ submit again. Okay. So what is this? This is VKQ submit, then a color pass here. This is vk cmd begin render clear, right? Then we actually draw the triangle. Then we end the rendering. And then here we have VKQ submit. Okay, for that command buffer. And then we have VKQ present. And then here VKQ submit. Then a color pass. So as you can see here, we're getting two frames because two in-flight frames. But anyway, so that's just a little thing there, I guess. It's pretty cool. We have two draw calls. You could actually get the statistics window here. So window, and then you say statistics viewer. So we have 24 API calls, two draw calls, and the API draw dispatch call ratio is 12, right? And 6 textures, what do you mean by that? 0 megabyte though, I don't know. Oh, 6 textures of the swap chain, because the swap chain, yeah. Anyways, whatever. So this is just a little something there. Can I launch the application and maybe see the performance counter? Would it give anything? Doesn't seem like, for some reason, I'm not sure why. But anyways, whatever. So anyway, let's continue. So today what we're gonna do, that's a good question. That's a good question. Let me make sure, by the way, to turn on the validation. And also I've actually enabled warning and performance messages too. Only errors were enabled, so all right. I think I'm gonna start with if we go to the rendering context, right? So here we're actually using a pipeline barrier, so the old version, right? But I want to use synchronization too. There's a new function. So I'm gonna do, well, actually, oops. So I'm gonna comment this out, and I'm gonna tell the AI to use CMD pipeline 2 instead, and see if it generates it. Yeah, exactly. Let's see if it did a good job or not. This method takes 2 arguments, but 5 arguments were supplied. I see. So let's just remove all of this then. And dependency info. So the second argument is dependency info, which contains everything basically. So here we had like everything were in arguments. Now everything is in a struct basically. And for whichever reason, there's no SRC stage mask apparently. Yeah, at least not here. In fact, not even the ST stage mask. Though dependency flags, yeah. So no, the AI didn't do a good job here, so we gotta do it ourselves. So there's dependency flags, which I don't think we care about. I'm not sure. Buffer memory barriers, we don't care about it here. Image memory barriers, that's exactly what we need. So let's go with that one. And then image memory barriers. We could have multiple images being transitioned at once, basically. But for now, let's just go with one image. Okay, so cool. But here we got pipeline stage flags 2, but found. Okay, so let's change that then. Access flags 2, I think, yeah. And pipeline stage flags 2. Okay, cool. And the same thing that we had here. Image, sub-resource range. Okay. For the aspect mask, by the way, we can actually automate this one. Not automate, but infer, basically. So we could remove it altogether. And then basically do, so we don't need this anymore, I think. Or let's keep it, you never know what could happen there. So yeah, let's actually right now say let aspect mask, there you go. So if new state.layout is equal to depth stencil attachment optimal, then we're gonna go with depth and stencil, else we're gonna go with color. So we're just impairing the aspect mask from the layout, right? So that's cool. That's cool. Or we could just inline it, really. Could inline it here. Where is it? Here. But honestly, no need. It's good like that, I guess. Alrighty. So what should I change else? And hold on, let me see if there's any other properties that are interesting here. So new layout or layout image, DST access mask, DST queue family index, DST stage mask, SRC access mask. Yeah, that's all. So that's cool. One thing that I'd like to think about is, would we want to support multiple image transitions at once? So we could maybe say like states. Why I want that? So like we could have one API call for all those transitions, but I'm not sure if that would actually work out great as I would expect it. But basically we're gonna have like a slice of tuples of image layout state, image layout state. So this is gonna be the source and this is the destination, I think. Though, hold on. Well, it's also gonna depend on the image too, yeah. So here we're gonna have vacate image, I think. So yeah, slice. Okay, that's cool. Let's actually right now do this. Honestly, just remove this. We have git, so if anything happens wrong, we could just reset the whole commit. Really, so no problem there. Okay. Hold on, what I've done. Okay, that's good. So how are we gonna do this now? I think it's doing it correctly already. Well, not CMD pipeline barrier, what the heck? CMD pipeline barrier 2. Okay, go on. So it's doing image memory barrier states.iterate. So it's iterating through all that states, all those states. We could actually make it into an iterator instead, really. Yeah, true. So like we could make it into an iterator. So like instead of a slice, you could have it as impl. I actually don't remember how you make iterators in Rust. I think item equal to. It's been quite a long time since I've touched Rust actually, other than like yesterday. But yeah. Well, not just yesterday, but whatever. Anyways. So is this correct? States.map. We're gonna map all of those: image, old state, new state. Image memory barrier 2khr default. Now the only problem with this is that we're gonna forcibly have to allocate a new vec, and I'm not sure if it's really worth it, honestly. Like an allocation. You know what? Let's keep it very simple. Let's not overcomplicate things, really. But that was an interesting idea that I could explore later on. But for now, let's just keep it very simple. So yeah. So let's just remove this old code. And this is what we got. We removed that aspect mask. We actually inferred it from the layout, and we're using synchronization 2 right now instead of synchronization like the default ones. Okay, so what do I have to change right now? Yeah, I have to change these. The other thing that I can actually do too here is that I could give some defaults for this image layout state. So what I could do, I could say implement default exactly. So the default would be defined for the layout, the stage mask, top of pie, not that. So like I was actually going through some tutorial here, some newer tutorial. This one, it's pretty good. I don't know why I have never gone through it. So the Vulkan guide. There's the link. It's a pretty good tutorial, though I remember maybe I was like, when I was a beginner, I kind of tried to follow through it, but it was very hard for me to understand because it does go through a lot of complicated things, right, and modern features. But anyways, where was the code that I wanted? Yeah, it was about synchronization. I think maybe here, rendering loop. Yeah, there you go. Synchronization. I really recommend this tutorial. It's very good. I just like read it just today. Well, not all of it, but yeah, at least not yet. But I'm surely gonna read all of it at some point. So where's the code that I wanted? Maybe here, let's see. Oh, it's probably in drawing with compute, maybe? New draw loop. Vulkan images. It's probably around a year. What? I don't remember where I've seen that synchronization. So basically, it's the vk pipeline access flags 2. Okay, let's search for that. Not here. Is it here? No. Here? No. Here? What? Not here either. Really? That's strange. Anyways, I think I do remember anyway. So here there's some more flags. So like instead of empty, let's see what we have here. There is none. Okay. Though empty, I think it does give us none. Yeah. So we could just go with none, yeah. For the layout and defined is a good one. Stage mask. Let's see what we got here. All commands. It's probably this one. All commands. So we basically would install the GPU or the queue or whatever until all the previous commands have been finished. So the stage mask basically, like if you do that, though you could give it some more like fine stage mask, so like you could overlap some operations. I could maybe explain it better later on. And hello Theo Paris, welcome to the live stream. How's it going, man? And then the queue family index, queue family ignored. Yeah, that's a good default. Yeah, that's pretty cool. Access mask, none. I think not none. It's probably here. It was like read and write or something like that. Man, I don't remember. Anyways, we're gonna see about that later on, honestly. You know what? Let's just remove this for now. I'm gonna come to it later on when I find the code that I was talking about. I don't remember what it was. Anyways, whatever. So here what we got. So the access mask would be vk access flags 2, basically none, right? And then what? So stage mask top of pipe access flags 2, none, and queue family ignored for now. The access mask here where it's gonna be, well, come on, flags 2, color attachment right, and pipeline flags color attachment output. Perfect. Yeah, there you go. Now what's going on with this? Okay, we can actually remove this. And what else? Could also remove this. And it takes 4 arguments by 5, okay. I think that's it. Let's make sure that everything is working well so far. We do have... Oh, the synchronization 2 feature was not enabled. What? I haven't? Interesting. So let's go to our context. Context. Where we're doing that. Okay, in in here. All right. So honestly, instead of doing these, what I'm gonna actually do is fit like features. What are you doing? The Marin Knight, welcome to the live stream. So I've just finished the triangle, and right now I'm kind of trying to change from like regular synchronization to synchronization 2 before we go on further. Physical device, features, and basically there was a struct for specific versions, and I don't remember what that struct is called. There you go. Okay, so like for dynamic rendering, it's inside Vulkan 1.3 core, so I could do this. And now I don't have just access to dynamic rendering, but also to some other stuff that are core in this version in 1.3, which is nice. I have no idea about this. You could watch the previous live stream. We're making a whole game engine currently. We're just focusing on the renderer. We're using, of course, Rust, and we're using the raw Vulkan binding in Rust, Ash, of course with Winit, the latest versions, of course. So that's basically, and also we're using Vulkan 1.3 with very modern features like dynamic rendering, synchronization 2, and hopefully in the future bindless descriptor indexing, device address, and blah blah, whichever. So we have all these features that we can actually enable right now, which includes also synchronization 2, which is great. So now instead of having like one struct per feature, you just like include one struct and it would have all the features there. I hope you get a lot of viewers. Thanks. Thank you, the Marin Knight. Okay, cool. Buffer device address, is it also here? No, it's not. It's probably in the 1.2 version. So push next. There you go. And buffer device address. There you go. Cool. Though for debugging later on, we're gonna need some other features there. But anyways, for now we're not using it yet. Also descriptor indexing, we're also going to use that one in the future, hopefully. I still don't understand it fully, but once I do, we're going to use it. Push next. Is there anything else? Buffer device address, synchronization 2. We're probably going to need some other features for descriptor indexing and like for bindless setup, but for now, whatever. All right, so where we were, oh yeah, let's try run now. And we're not getting those validation errors anymore, which is perfect. Okay, cool. What else? What else we could use synchronization 2 in? Let's see. Present. I think there is a present. Another. Well, not here though. Let's go here maybe. And I think there is Q present 2. Let's see. So like self.context.swapchain_extension.q_present. No, there's not. I'm wrong on that one. But I think acquire next image. I believe this one also have a second version, though it's not really useful in my case, I think. But why not? We could just use it anyways. Acquire next image info KHR default. Right. And let me actually get it from here and get it here, around here. And I could just comment this out. So hopefully the AI would understand what I'm trying to do here. Cool. So acquire next image 2, it takes a struct instead of parameters, which is more consistent with what Vulkan usually does. And that's cool. So the swap chain, the timeout, The timeout and the semaphore image available. Semaphore, perfect, and the fence. Is there any other things here? So there's device mask, basically for multiple devices, though here we're not actually using multiple devices, so we don't care about that one. So that's one thing. Okay, cool. What's next? Let me just make sure that this is actually functional with no problems. Oh boy, it's not. So acquire info device mask is 0. It's probably should be 1. That's why I always test out any changes that I do before I go to the next change, because otherwise I'd be totally lost. Okay, is it here? No, my bad. Let's go here and dot device mask, and it's probably supposed to be 1 instead of 0 when you have one device. And yeah, perfect. The other function I think is qsubmit. So self.context.device.qsubmit2. Okay. I should probably put the graphics queue in a variable, but yeah. And here this is totally wrong apparently. So we're gonna do something like, but no, it doesn't like it. No, there's actually command buffer infos here, and there you go. Is there any other command? There's device mask. Maybe I need to set it as 1 again. That's kind of sucks. Anyways, what else? So command buffer infos and RH. So here. So command buffer infos like this. Dot signal semaphore infos and wait. So let's see what we got here. Whoa. Is there a device mask here? I don't think. No, there is not. Though there is some extra values for, I think, yeah, for timeline semaphores, which we're not going to use for now. What the heck have happened here? So expected semaphore submit info, but found semaphore wait info. Walaikum assalam wa GG Kirin, welcome to the live stream. Good, it's good night for me. Dot semaphore. Okay. Whoops. Go back. And there's dot sage mask apparently here. Oh boy. And what's wrong with this too? And then signal semaphore infos. The AI really failed horribly here. What the heck? Hold on, no. Signal. Is there anything other than that, here dot semaphore, and there's also a stage mask which it didn't include once again. Oh, apparently right now we have two stage masks. One for the wait and one for the signal, I think. Here though we only had one, I believe, which is interesting. Is there anything else? Stage mask, value, device index. Yeah, I think this is it, probably. Now the problem is what these stage mask means. So with semaphore info on the stage mask, color attachment output, and signal semaphore infos. Well, I guess let's try this out and find out the hard way. So let's see. And there doesn't seem to be any error though, so I guess we're good. We're good. Perfect. Though I don't really understand these stage masks. Let me see one thing. Are these stage masks correct? For the synchronization, I mean it said so, but no clue. Anyways, it seems to be about right for now. Alright, what else? CMD and rendering. Yeah, that's basically it. One other thing that I'm gonna do is I'm gonna take this begin rendering function. So all this rendering code, I'm gonna put it in its own function. So we're gonna have self dot, let's say, draw, and then we're gonna pass in the command buffer and maybe the image index or whatever. We're gonna see how it goes. Pubfn render. So pubfn draw, and we're gonna paste in all of that. Of course, we're gonna get self here, and we're gonna need the frame. What else? Okay, so we need some in safe code there. And we also gonna need the image index. U32. Though. It would have been nice if CMD begin rendering. So basically what I'm thinking about is to actually take this begin rendering and put it in the other function, not in the draw function. Yeah, honestly. And with that out of the way, we actually wouldn't need the image index anymore, just the frame. And what about the command buffer? Where is it? Oh yeah, it's from the frame. Yeah, that makes sense. And let's remove this from here. And let's go here. Let's do this. Do this. And actually just give it the frame. And in fact, maybe we don't even need really the frame. It's just like the command buffer alone, really. So yeah, I mean, we could go ahead and do that too. So like we could say, instead of the frame, we could just say, well, command buffer alone. And And of course, let me not forget the end rendering function. Well, device end rendering. There you go, cool. And here instead of frame, we're just gonna pass in the command buffer. And what else? Cannot be applied to type. Yeah, so there's no errors, at least for now. CMD end rendering. Perfect. So begin rendering, then the draw calls gets called here, and then we end the rendering. Perfect. Command buffer, we're gonna do this, 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 and this, and there you go. Just a little bit of organization there, pretty much. So these are the actual draw calls. Set viewport, set scissor. Well, not draw calls, but basically of the rendering, right? So the calls of the rendering, or the commands of the rendering, and we draw. Okay, cool. Now, one thing that I'd like to do is to, instead of render to the swap chain directly, we want to render to another image first, and then copy that image to the swap chain. Why? That would be useful because we don't know what's gonna be the swap chain format that would be available for the swap chain, basically. So it could be basically anything, which gonna suck, first of all, and second of all, it's gonna be limited in precision. It's just gonna be 8-bit, right? And it's not gonna be float. It's just gonna be like an integer, like from 0 to 255 in the case of 8 bits. Which is not enough for, let's say, HDR, you know, high precision rendering and so on, and other techniques, and like more precise lighting and so on. So that's gonna suck. What we actually want, we want the rendering to be in floating integer and like 16-bit per component. It's kind of an overkill, but we're gonna go with that. And so basically 64-bit per pixel, right? Yeah, I think so. So that's gonna give us a lot of precision for all of our rendering techniques, basically. That's the first thing. Second thing, it may allow us to actually decouple the renderer from the swap chain. And so you could have a renderer that doesn't need an actual window or like a swap chain. Like the renderer would be separate, it would be just like rendering to an image. And so that would allow us to even go ahead and work with headless renderers, right? And things like render targets and so on, like basically offline render targets and so on. That would be very interesting. Either way, all of these would be amazing to have. So I'm gonna take a little break, just 5 minutes. I'm gonna be back. Gonna be back soon, right? And yeah. Okay, back. So mic is on, camera's on. Perfect. Let's keep going. All right. So let's actually start implementing that thing. So the first thing that we have to do this is to actually create an image. And creating an image in Vulkan is not as easy as it sounds. You have to allocate it, and to allocate it efficiently. So we're gonna try to use what is it called? Yeah, that GPU allocator that I talked about in the first episode, like the first live stream. Though I did have some issues with it before, but hopefully this time it would work. If it doesn't, then, well, we're gonna switch up. So yeah, first of all, let me actually just submit these changes to a commit here. I don't think there is other functions that we want to upgrade. Let me just make sure we have no other functions that we want to upgrade beforehand. Let me see. I don't think. Let's see. Rendering. No, renderer. So Lloyd shader module. Reset fences. I don't think so. Context.device. So there's qsubmit 2, qpipeline barrier 2, begin render pass, bind image memory 2. Okay. Yeah, I don't think so. At least not now. Okay, device q2. Ooh. That's interesting. So let's go to our context here. And let's go to get device queue. Oh, I see now why that search is broken. Okay. So can I use here get device q2 instead? So it needs device q info to default. So here you just give it a Q family index and then a Q index. I don't think it was changed a lot. It's just that right now it's a struct. So yeah. So far we have no problems, right? Yes, we don't. Perfect. Okay, let's actually just commit this stuff. I don't think we only upgraded the functions, right? That's all the changes we have done, I think. And the features too. But yeah, we could just say upgrade to newer functions and synchronization too. That's basically what we have done right now. Right, and let's actually commit. All right, now we can start on our new feature. So let's actually add GPU allocator library. Hopefully it would work, because I really don't want to manage the allocations myself, because if I do it, it's not going to be as efficient. So yeah, and it's just a lot of stupid work, right? And I could easily break it, right? So anyways, GPU allocator Rust, GPU-allocator. So basically in OpenGL, you just create a buffer and that's it. Like the allocations are handled for you. But in Vulkan, the actual allocations, like you have full control over it, you do it manually. But unless if you're a genius, I don't recommend to do that. Cargo add GPU allocator. Though I'm gonna disable the default features, only include Vulkan, because it can allocate for DX12 and also Vulkan. I don't need DX12 here. So I'm gonna say version is equal to that, and then default features is equal to false, and then the features would be equal to Vulkan. As simple as that. And now let's go to, we don't need main RS here. Let's go to the renderer, yeah? Or is it? The renderer, yeah, okay, I guess. And we're gonna have an allocator here. And where are we gonna put it? Let's put it here for now. We'll see later on where we're gonna put it exactly. So GPU allocator, Vulkan allocator, there you go. And let's actually create an allocator here. Let allocator is equal to allocator new. Well, that's not the way to do it, I guess. Let's check out here the stuff, setting up. Okay, so this is how you do it. Though we could, you know what, I'm just gonna say rendering context. Context dot create allocator, too simply. And we're gonna need just the debug settings and the allocation sizes, which are gonna be both defaults values for now. Now let's actually create this function in the rendering context. I need the train to go through all of this. So pubfn create allocator. Okay, and let's just copy this code right here. Do it like that. Let's import GPU allocator. Allocator create description. Then here self.instance, self.device, and self.physical device. I believe. Self-expect, what? Oh yeah, since that's the case, right now we actually have to do it this way, because it's no longer the same name. Whoops. And I believe that's it. Cannot move. Yeah, this one's actually takes clones. And it's actually fine to clone them. And no, not physical device, of course, I think. Though we gotta pass in the actual handle, not our custom physical device. And we're already doing buffer device address. So that's fine. Cool. And we're just gonna give this back. So allocator new. So GPU allocator result. Can I actually use that? It's private. Well, that sucks. I don't know. So let's just go with that one and say okay, and this and that. Perfect. Okay, that's good. Perfect. Of course, the debug settings here should be allocator debug settings and allocation sizes. Perfect. Okay, now let's see, and there you go. Let's just unwrap this result, and we got our allocator. Perfect. And let's add it to our struct here, and it should be okay. Let's see if it does give any errors, because it does call some functions and so on. Am I having the allocator on? Yes, I do. Cool. Alright, so let's try to create a freaking image. How are we gonna do that? Good question. So first of all, I'm probably gonna have a struct for an image. So to keep things very simple. So we're gonna have a handle, an allocation, and a default view. Right. A default view, format, extend, and we're also going to keep track of flyout, which would allow us to maybe automate some step in the, well, what is it called? Yeah, the transitions of the image layouts, but whatever. So actually, image layout state, that's, I'm not sure if that's a good idea. Yeah, probably. Key family index U32. Probably. Okay, anyways, we'll see how it goes. So now let's actually create a function to create an image. So pub fn create image. And let's see what the AI would do here. Oh boy. Okay, cool. So the extent, the format, the usage, and an allocation. Not what? Why would you need an allocation? You need the allocator, dude. Whoops. I have no clue. Oh, there you go. Okay. So first of all, you're gonna get the self. That's the first thing. And the second thing, you're gonna get the allocator. These are the things that you need first of all. And then extend, format, blah, 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 whichever. Okay, let's see what's happening here. So we're saying self.device.create image. Image type 2D. So it is assuming that it is 2D, that's which is fine for now. As samples type 1. No. No. So we don't want to assume at least the usage flags, that's for sure. Vk usage flags. Let's put it here. Sharing mode, we're gonna see about that later on. For now, we don't care. The initial layout, I mean, that could be useful, but for now, let's keep it as undefined, I think. I don't know, we'll see. So let allocation, and that looks not right. So let's see how we can actually do an allocation here. Though this one is for a buffer, apparently. So I have to probably realize how to do it myself, I guess. So here they're creating a buffer. Then they're getting the requirements of the buffer. And they're passing it the buffer. Let's see what we got. We only have one allocate function apparently, which is interesting. So first thing first, let's actually remove all this stuff really. First thing first, we're gonna need the requirements of the image. So get memory requirements. Though I do remember there was like a get memory requirements too. I'm not sure what this adds. You give it the info. Vacate memory requirements too. I'm not sure what that adds exactly, but let's just go with the default one, honestly, for now. Memory requirements, there you go. What else? Let's just say let allocation now is equal to allocator dot allocate. And here we need allocation create description. Right, and let's see what we got. Add the missing fields. So we got the name, first of all. So I mean, fine, we could give it the name, why not? We got the requirement, then the location in memory. we're gonna need that too, sure. Memory location. So memory location, and so we could just do this. Linear, no, since this is an image, it shouldn't be linear. I mean, it could be linear though. Like if you want it to be read back from the CPU, then you do want it to be linear, actually. So yeah, we're gonna include that too, I think. Yeah, sure. Let's say is linear, or let's just say linear bool, and we can pass that too. Allocation scheme, same thing. We're gonna pass it through a parameter, though we probably want to put these into its own struct because this is going crazy. Okay, allocation scheme. Alright, allocator cannot borrow as immutable. Okay, so for the allocator here, you can actually just get a mutable allocator reference, honestly. Okay. And then we could create an image view for it. And there you go. Stage mask empty, empty, empty. Perfect. I think that's maybe it. No? The function has too many arguments. There you go. Okay. So let's say pub struct image, I don't know, attributes. And let's have all of that there. Oh no, I don't want to store. I mean, it's a static stir though. Meh. Just allocate a string, please. I don't want to deal with reference lifetime shit, so. Okay, cool. So the allocator and or actually we could remove the name from here. Okay, fine, let's remove the name from there. And let's just say allocator and the name only. And then we got the attributes. And alrighty. Now we're gonna say attributes.format. And the attributes.extent. And attribute.usageFlags. And attributes.location. Well, we're gonna say now location attributes.linear, yeah. I'm gonna say linear, and finally the allocation scheme. Actually, gotta say attributes.allocation scheme. Okay, cool. Attributes.format here. Well, actually we do not need to put it here. So we could just remove those extent and format. Well, not here. I mean in the image itself, so we don't need them. And instead, we could just store the actual struct of attributes. That's why I didn't want to include that string reference there, because I'm gonna store it into the struct and I don't want to deal with that crazy lifetimes. It just goes viral. Anyways, attributes, add missing fields, and there you go. There you go. Attributes.format here, and hopefully this would work. And finally, we're gonna have like a function to destroy the image. So we're gonna destroy the image view, then allocator.deallocate. No method named deallocate found for mutable reference in the current scope. No method named deallocate. Free, it's probably called free. There you go. Though, let's do this, I guess. Dash results. And finally, let's say, oops. Let's say okay. Yeah. Cool. Though, I'm gonna add one more thing, which is it owned or not? Is the image owned? But no, if I do that, then I'm gonna have to deal with the allocation too. Well, there is a nice thing that we could do. We could actually make the allocation an option. And that would basically tell you if it is owned or not, right? Yeah, that's genius. So option allocation, right? And I'm gonna use this for the swap chain images because they're not owned, right? So I shouldn't destroy them basically. Oopsies, that's not what I meant. I meant here. This should be allocation, some allocation. And here free allocator.free. Well, if let some allocation, then we gotta go ahead and free it, basically. And there you go. That's too simply it. So now why I've done this, so we could actually go ahead and let's say, for example, swap chain images, which are not allocated by us, they're allocated by the windowing system. We could just say none for the allocation, and if you want to know if it's owned or not, you could just see if the allocation is none or some allocation. Perfect. Okay, so I think that's it for that one. Let's try right now to create an allocation, an image. So where are we gonna do that? Probably in the render, in the new function for now. It may go, actually no. Here, I'm probably gonna call it render target, honestly. That makes sense to me. And of course it's gonna be called image, right? Perfect. Now let's see what the AI would do with that. So let render target is equal to image new. And that's cool, though we're not gonna have a clone here for now. Oh, no, that's not how you do it. Device, I'd like to make it OOP later on, but not yet. Let's keep it simple for now. So context.create image, basically, and apparently filled horribly. So let's just give it the allocator, I think, or actually a mutable reference to allocator. Make allocator mutable, yeah. What the heck is going on here? So expected string, okay. So this is like the render target, basically. Oh, but though, hold on a second. No, we have to have a separate render target for every frame, I think. Yeah, probably. Is it? Good question. Well, let's just go with this for now and see what's gonna happen. Let's find out the hard way, I guess. And yeah, the AI failed horribly here. Let's see what we got. We got the name, we got the attribute, yeah. So image attributes. And so the extent is swapchain.extent. Expected extent 3D but found ash definition extent 2D. I see. Now, honestly, fine, let's just do it regularly, whichever. Where I was here. Okay. So let's just say extends 3D. Default dot width, swapchain extend width, and height. Format is this, not swapchain format really, no. We're gonna go with our custom format, well, our own format. So we're gonna go with vk format. So basically we're free in the format that we, well, actually it does depend on the physical device, I think, but whatever. So here we're gonna go with B16, G16 probably, BGR16, but there's no, what? Well, let's see the sRGB stuff, right? So these are the available sRGB. Actually, do I really want sRGB? Hold on. No, hold on. I want float, sfloat. Yeah, my bad. So G16. Well, actually B16, G16. But there's no sfloat there. What the heck? So these are the available ones is sfloat. R16, G16. Okay, so there's no BGRA apparently here, which is interesting. Okay, cool. So let's go then with this one right here. R16, G16, B16, A16, sfloat. So this is basically the precision that we want, and the most important thing is sfloat. So here usage, no such field apparently. Why that's the case? Well, let's just call this usage, sure. And this is gonna be a color attachment, so we could actually render to it. But we're also gonna need some other stuff. We're gonna need transfer src, so we could actually copy that, like copy this image to as a source to the swapchain image as a destination. And we're also going to need transfer DST because we're going to clear the image manually using a command, using transfer command. So we're also going to need that. Is there anything we're going to need other than that? And later on, if you want some like compute shader accessing this image, then we do want storage too. But right now, I think this is enough. Okay, what's else? The trait is not satisfied. No, we don't need that, I think. What the heck? So what's wrong? Missing field location allocation scheme. Okay. So where are we gonna put this? Vacate image. Of course, this is gonna be, well, no, not that. Memory. Location. So we have some options here, but we're gonna go with GPU only. right? So we only need this image to be like in the VRAM basically. So cool. So like the video memory or like the GPU memory, not the physical memory of the CPU. And what else? What we're gonna need is allocation scheme. And is it linear? Linear, no. You only want this, as I said, if you want to read back the image to the CPU, right? Because you cannot read it from the CPU if it's not linear. The other thing is, and otherwise if you access a linear image in the GPU, it would be very inefficient. What else? So we've got the allocation scheme. For this one, I'm not gonna bother. Probably, hold on. Allocation scheme. You could say dedicated buffer, dedicated image. For here, I'm just gonna say GPU allocator managed. I don't care. That's basically it. So cool. Cool. So that's our render target. Let's see if there's any errors so far. And before that, actually, let's make sure to drop it properly too. So in safe self dot, well, not that, what the heck, context dot destroy image. What the heck? So we only need the image and the allocator pretty much. So self.render target and self.allocator, I think. And use results. We're just gonna, well, oh, not here first of all. It should be in the drop trait. Here you go. Okay, so that's how or why. Oh, well, wait first of all, wait idle. Then, yeah, we're gonna destroy the image. Render target. What's going on with this? So expected but found image. Oh no, context dot destroy image. Okay, what else? In wrap, I think. Expected image but found mutable allocator. And honestly, it does make sense to do it that way, in my opinion. Okay, and let's go to cannot move. Oh boy. Well, we could just probably clone it. It's probably fine. Actually, not fine. It's gonna clone the allocation. Yikes. So that's really annoying. Let's go to the render. Where is it? Oh boy. Why my render is gone? So how are we gonna fix this? Basically, it cannot move. Do I actually need... I mean, I could just get a reference anyways. Although, yeah, it is owning it, but can I do that? Cannot move. Hello, Loop Luminary. Welcome to the live stream. Yeah, it does actually need the allocation itself, apparently. So I can't do that. Actually, I can. I think, because it's I think I could say, because allocation is an option, so maybe I could say allocation dot take. Yeah, so I could leave a none there. Yeah, perfect. So cool. Now I think we're not gonna have that problem anymore. There you go. So just a borrow checker crap. Okay, let's try this out. In known fields, that makes sense because we renamed it. And we do have some errors. For depth here, okay. Where's the depth? Extents.depth. Oh yeah, I see what's happening there. For that, we have to go back here. And make sure that the depth is 1. And okay. Now used, oh yeah, I didn't bind the memory. I didn't bind the allocation. So that makes sense. Okay. So after we get the allocation, we have to bind it. So self dot device dot bind image memory. And it's an unsafe function. So attempt to access for field type. And there you go. And I think that's it, right? And we have no errors. Perfect. And when you exit, there's no errors either. Cool, lovely. So that's great. We have created an image now. Next up, we actually gotta clear it. So how are we gonna do that? Well, pub fn clear image. And we're basically gonna give it a color. So we're gonna get the image here. And let's see what it's gonna do. Okay. Oh no, it does need a command buffer, yeah. Makes sense. Command buffer. Well, vacay command buffer, yeah. Perfect. Let's go. Oh, what the heck? No, that's not how you do it. Let's say self dot device, yeah. Dot cmd clear color image. Well, it actually does depend if it's a depth image or what exactly, but anyways, let's just go with this and call into an unsafe function. There you go. Alrighty. The aspect mask, it would depend. I guess. Or honestly, let's not worry about the depth image for now. Fine. So here, image layout general. You probably want it to be in transfer dst optimal, I think, because that's a transfer command. Let's check that out. Clear color image. So clear regions of a color image. Anyways, let's go with that one. And here we get the clear color. Now this depends on the format, but I'm just gonna hard code it for now to be float. Yeah, because I don't want to handle that format conversion crap. But anyways, so the clear color would be I think if 32.4, yeah. And there you go. That's it, I think. So now here, like right now, if I actually run this in render doc, I can show you the texture being there. So like if I launch this and I capture some frame real quick, I think I could probably show you the texture. In resources. Now these are swap chain images. I guess maybe have to be used by the rendering frame. Yeah, probably. That's why it didn't show up here yet. So, okay, well, never mind then. Alright, cool. So, where are we gonna do this? Reset command buffer, begin command buffer, begin rendering. So we're not gonna render into the swap chain anymore. We're gonna render into that render target. .view, of course. And we don't want to clear anymore. Actually, yeah, why not clearing using that then? I mean, I think it does make sense to clear it with that. I mean, fine. Okay. So now, instead of transitioning the image layout here of the swap chain from the defined image state to renderable image state, we gotta do it for the render target instead. And what's going on here? Probably handle, yeah. Begin command buffer, begin rendering, self.draw, and rendering. And then we have here transitioning the image layout from the renderable state to the present image state. Well, here for the swap chain, it's got to go from indefined to presentable image state. And for the render target, it's going to go from renderable to another kind of state that we're going to do. So image layout state. So it's got to go from transfer src optimal. Well, actually right now it's in the renderable state, right? Yes. and then you gotta go to transfer src because we're gonna copy it over to the swap chain. Transfer read, transfer key family index. Yeah, cool. So basically what I'm doing is transition the swap chain image to present layout, and here I'm transitioning the render target image to transfer source layout. And after that, I could actually go ahead and basically copy the render target image to the swap chain image, which is going to be great. Now let's make another. And by the way, when we transition the image layout, oh well, it's still using vacate image apparently. We can actually make it use image instead. So we could make use of something there, because if we do that, then we no longer need the old state. Well, actually, you know what? Let's keep it very simple right now. I don't want to go that crazy yet. Yeah, let's go step by step because that's gonna get crazy real quick. Let's go copy image, and let's see what it's gonna do here. So yeah, we get the command buffer, perfect. The src image, the src layout, destination image, destination layout, extent. Okay, let's see what we got here. It takes 6 arguments, but got 7. Okay, so we give it command buffer, src image, src layout. Is that correct? Destination image, then destination layout, and the regions. Being, yeah, default, extent. Yeah, I mean, let's try that out. So let's go. Self.context.copy image. Let's see. Nope. So first of all is the command buffer, and the source is the render target. And the other one is the source layout. So self.renderTarget.layout. But no, I can't do that just yet. I'm not updating the layouts just yet, so I gotta do it manually for now. src. Well, actually, no, we don't need really the layout because I already. Hold on. Let's go to copy image here, and let's just remove these src layout and destination layout. Right, just src image, dsc image. Pretty much. And here for the src layout, we're just gonna say transfer src optimal, and here transfer DST optimal. That's pretty much it. Let's go, but found image dot handle here. But no, that's the you got the src image, then the destination image. So instead of render target, we're gonna go with the swap chain image. Swap chain dot images image index, right? Yeah. And finally the extent and self.swapchain.extent, but that's to the extent apparently. Yikes. What about the render target.extent? The attributes, yeah. There you go, cool. So That seems about right to me. Transition the render target image to transfer source layout. Well, actually here we should really make it into transfer DST layout first. So into transfer destination layout. Copy the render target, and then we gotta make it into a present layout. So honestly, that kind of suck. These, hold on, where is it? Yeah, these image states right here, they suck. Let's just do it manually, honestly. Well, you know what? Just keep them for now, please. Yeah, all right. And let's see if this craziness works or not. There's a lot of crap right there. Yeah, let's just see what's gonna happen, honestly. Let's save this first, and let's see. I've never done this before, honestly. I should change the format in the pipeline too. So where we're creating the pipeline though, I think create pipeline. Here you go. Okay. Here I'm actually saying swap chain.format, but no, we want now self.render target. And oh my god, so when the swap chain gets resized, we should also recreate the render target. Yikes. So yeah, we're gonna need the render target here. Give me this guy, please. Go on maybe somewhere around here, or you know what, go on here, please. And let's go. Oh, I also need the allocator apparently, so let's grab that too. Okay. Now here, what we're gonna do is render target, the attributes.format. Well, extend probably. No? What is it? Ah, I see. It needs an extend 2D. Well, that sucks. Whoops. Well, not the swap chain. We're gonna go with the render target. And same thing with the height. There you go. And the format of the actual render target. Because we're not rendering to the swap chain anymore. We're rendering to the render target. Cool. And let's see what's gonna happen now. What other errors we're gonna get? Oh boy, that's a lot of crap. Let's see. So vk cmd pipeline barrier 2 new layout. Oh, the swap chain image. Let's go to that. So here, okay. Where is the, so here, image usage. So instead of color attachment, in our case, it's going to be transfer DST. And what else? Is there anything else? No. just transfer DST. We're no longer rendering to it directly. We're only doing a copy operation. Okay, what else? Oh boy. Image must have been created with a usage valid containing at least one of the users to find the valid image. Which one is it talking about? Was created with image transfer SRC bit. Oh, it probably also needs that color attachment anyways. What else? Aspect mask is 0 in VKCMD copy image. Let's see. Can I see that message again? So where is that? In sub-resource layers. Okay. Layer count 1. Layer count aspect mask color. And what else? Anything else? Probably not. Maybe mid level 1. No, actually no. So this is it. And let's see. I mean, we're getting something. It's not perfect, but we're getting something. What's up? Triangle. This is not a multi-planar format. The VK format of H must be size compatible. Okay. So we can't actually use VKCMD copy. It's actually more efficient, it's faster, but it does have some constraints. Like apparently it have to have the same size of the format, but of course it's not. The other thing also, like, it gotta have the same resolution, I think, and so on, which is not the case here. Though it still worked, it just kind of was like all over the place. So we shouldn't use copy image. We should use blit image instead, apparently. So yeah, and we're probably gonna need src extent, I think, and then a destination extent. Now the actual nice thing about this, well, let's just remove this for now. The actual nice thing about this is that we can actually also like create the render target. It doesn't have to match the swap chain image resolution. It can be bigger, it could be smaller, you know. So you could upscale it, you could whatever. So let's see, CMD blit image. There you go. And what's up? Come on, dude. And let's see what's up. All right, so we got the SRC image, that's good. And we got the regions. You could have multiple regions, but we only have one. SRC sub-resource, aspect mask, blah, blah. Honestly, have the sub-resource here, please. It's equal to that. And so I could just use it here, because I don't care about the sub-resource. This is for some more advanced image formats that I don't care about right now. What else? SRC offsets, offset 3D default. Okay, cool. Oh, I see. So extend.width, extend.height. Yeah, that works for now. Though we could actually say src extent. And destination extent. And we could actually replace them here. There you go. There you go. No need for extent anymore though. You could also change the offset, like the starting point of the offset, but let's not bother with this right now. Yeah. So let's go to where we're actually using this. Copy image. Now we're not using copy image anymore. We're using blit image. Okay, that sucks. We're just gonna say vacate extent 3D, or we could just say self.render target attributes.extent, and same thing in here. I think. Well, just use the render target extent too. Why not? So a full copy. Anyways, I mean, it's supposed to actually be swap chain here though. I mean, fine, whatever. Let's say extend 3D. There you go. And that's basically it. And let's hope this actually works now. I mean, we're getting our triangle back, which is great. But what's the other problem that we have here? Is of type. So what's going on? So destination offsets 1.0 is 0, but destination image. Oh, hold on. What does that even mean? Hold on. So P region 0, destination offset 0 is 0. So maybe it's supposed to be 1 here actually. Maybe. Actually, oh boy. It's saying destination offsets dot z. Dot 0. No, but it's talking about this one, I think. I mean, is it supposed to be 1 like that? That's strange, but let's see, that would help. No, it maybe should be 0, but the other one should be 1. I'm very confused right now. Very confused. You know what? I'm gonna do something interesting. I'm gonna copy this and see what the AI could do for me here real quick, instead of me trying to search it up. Let's see if he can handle it. So here it should be 1. There you go. So it actually works. Interesting. Let's try to launch this here. Let's grab a frame. And let's see what we got. Where is my copy function? That's weird. Okay, so why the heck I have no inputs here? These are not the commands that I've actually made. Where is the copy command? What the heck? Or maybe it only gives me the draw calls? That's strange. Yeah. That's very strange. Oh, hold on. This is weird. Let me try again. Oh, hold on a second. I have a little problem here that I've forgot about. Let's remove this too. So I forgot one little thing, which is here. Bruh. Yeah, I'm actually using the release mode, which shouldn't be the case. So that's why. That makes sense now. Let's actually grab the debug mode one. Copy path, absolute path, and let's put it here. And yeah, let's launch. And right now we're actually using the new one. So let's try to print a frame, and let's see. Oh, right. Yeah, now we have the command that we added. Perfect. So let's see what we got. So as you can see here, the blit image right here, the SRC is our render target, and the output is our swap chain. You can notice here that our render target is the format that we have picked, R16, G16, and so on. And it should be way more precision. And in fact, if we do the same with outputs, well, first of all, it's sRGB. So that changed. While the other one is not. It's linear, right? There's no sRGB conversions there. But also the precision should be more. But I can't really notice for whichever reason. Strange. Maybe it should be bigger, just for me to notice. But anyways, so So that's basically it. So it actually works. Lovely. Now, first of all, of course, I'm gonna actually go ahead and commit this stuff first, because I don't want to mess it up. Carry a YAML mod, blah blah, whatever. Add an intermediate render, or like add render target. Right? Let's commit this stuff. And so the next thing that I'm thinking about right now. Oh, debug settings is never used. My bad. Let's actually remove this and remove this. Perfect. Okay, let's amend this commit real quick. Just a little thing. Cool. All right. So what I'm thinking about right now is to decouple the renderer from the actual swap chain. So like you could actually make, you know, hold on. You could make like a offline render target, like just a simple image, not like a window, not a swap chain, things like that. And then you could render to that. How are we gonna do that? And is it even possible? I mean, it should be possible, but so like we could remove window, right? So we're supposed to remove the window, and we're supposed to remove the swap chain from here. All right, so yeah, we don't have any swap chain anymore. But we're gonna need some resolution right now, or we could just grab any image. No, I think we could just like, it's better to create our own render target for every single renderer, I think. Yeah, probably. So you gotta have the resolution basically, which let's just say U32, U32, I think for now, and then we're gonna say resolution.0 and resolution.1, and then here the format. You could also change the format to whatever you want. It's going to be a VK format. Like you could actually control all of these stuff about the renderer right now, which would be cool. I'm not sure if this is going to work, but we'll see. Color attachment, transfer SRC, and transfer DST. Oh, cool. So what else? What else? So far we're good. Here we're actually setting the swap chain to dirty. And oh, I forgot one little thing, is that right now we're supposed to resize the image too. Though I don't think you can resize an image in Vulkan, you have to just recreate it basically. So we're gonna come to that in a second. What else? Now the synchronization is not really supposed to be here, I think. Or is it? In-flight fence. Let's just remove the swap chain stuff and see what's gonna happen. Type mutable renderer. Acquire next image. So we don't have probably to wait for anything really. Okay, and frame, but we do need a I'm not sure how that would fit up there. So in flight frames, should it be part of the swap chain or the renderer? Let's see what the AI would say. I think of the swap chain, probably. Yeah, probably the swap chain. Yeah, because like you need that synchronization stuff for the swap chain, not really for the renderer. Yeah, probably. But what about the command buffer? How are you gonna handle that? Well, you do need the same command buffer, I think. So let's just remove that synchronization stuff from here. I think this probably should go into the swap chain. Though we do want to be able to like, hold on. Frame.command buffer. This probably would fail. I should really get more time to think about this first, but let me just experiment a bit. Just see if this is... So here we're beginning the command buffer. I think we're probably gonna, let's just assume that we're actually gonna get the command buffer outside. Maybe. We'll see. And we're not gonna do the begin stuff here. Oh boy, there's a lot of crap here. So here we're beginning the rendering. We're in the find. We no longer need to care about presentation. And here we have the command buffer directly. Begin the rendering, and oopsies, this should be the render target extent. Oh boy, I hate this. It needs it to be a vk extent 2D. Alrighty, default dot width. Well, not that. What the heck, dude? Say self.render target. There you go. Remove this. Do this. Right, hold on. Transition the swap chain image. No, we don't care about the swap chain images anymore. Transition the render target image to transfer source layout. Not necessarily. That's the job, again, I think, of the swap chain or whatever. Copy the render target image to the swap chain image, same thing. Transition the swap chain, same thing. And no, maybe we're not gonna end the command buffer actually. Well, I guess no. Yikes. I don't think this would work. In rendering. But it kind of matches that begin rendering and end rendering thing, which is interesting. Right. No need for this anymore. Pa-pa-pa. Whoops. What's going on here? Oh my god, I have to do that thing again. Oh boy. Command bind pipeline, command draw. And we don't have that stuff anymore, no? So here frames and frame index, in flight frames count. So you just got an allocator, a command pool, pipeline, pipeline layout, context, render target. Interesting. No need for these anymore, apparently, I think. In flight frames count. In flight frame counts too. And command pool. No, we don't need that either. So only allocator, pipeline, pipeline layout, rendering context, and the render target. Yeah. And what else? Here we actually have to recreate the image. Is there any other problem here? Device wait idle. And then we destroy the image. No field frames in type mutable renderer. No, we don't need these anymore here. And no field command pool in type mutable renderer. Yeah, we don't have a command pool anymore either. And we have one small error left, which is this, which is basically we gotta recreate the render target. So we gotta actually create a function here. Well, in fact, yeah, pretty much create render target. Okay. I think it probably did the same code, right? Yeah, apparently. So that's cool. So now the render target is equal to create render target. And yeah. And so here, when we resize, you gotta give it the new resolution. Which again would be U32, I think. And well, you just gotta say self.render target. Well, you actually gotta destroy it first. So self.context destroy image, and then self dot, well, yeah, render target, we gotta recreate it again. Yeah, pretty much. Destroy the old render target and create a new one. Now you probably also maybe wanna update some fields. No, there's no fields to update for now. Perfect. And yeah, there you go. That's pretty cool. Pretty cool stuff. And honestly, let's just remove that thing. Let's just do it directly and line it basically. Same thing here. And yeah, so this is the idea that I have, is that the render would be decoupled entirely from the swap chain and the windows and so on. So you could actually have an offline renderer, right, which have its own internal render target. Yeah. And basically, if you actually want to use it in the swap chain, you gotta basically copy it over. That's basically the idea here. How much time has been? 2 hours. Okay. Draw command buffer. Well, we don't actually no, it's good. Begin rendering, draw and rendering. Let's just transition it to transfer SRC, because it is expected that you want to do that, I think. But no, not necessarily. What else you could do with that? I mean, you could, for example, let's say maybe use the image for other purposes, like as an attachment to a shader. Or something like that. Not necessarily for... Yeah, I mean, that's true. So pretty much the only render code is actually ends at end rendering. And yeah, begin rendering. That's pretty cool. And here's the clear color essentially. It's a vk clear color value. And here the user is supposed to know, depending on the renderer format that he chose, which one to pick, which field. And so yeah, pretty much. So I think I'm gonna have a little break and then we can come back. Okay, I'm back with 10 minutes though. But I'm already quite tired. Alright, I thought about it a bit. I do think it's a good idea. It would give us offline renders and so on. So let me copy this code and put it somewhere else. Whoops. Let's copy this code here. Let's actually, where is that thing? Well, whatever. And I'm gonna actually go ahead and revert the changes that I've done here, because I do need that code. Rollback. Yeah. Yeah. And so we're back to our old render. I'm gonna create another Scratch file. Whatever. And I'm gonna put this rendered thing there. Gonna copy this stuff. Gonna put it here. Though it would be great if I can rename this to Rust. Same thing here. To Rust. And so basically, let me copy that new code of the renderer here. And that's essentially it. Perfect. Now I do have access to that old renderer code, so I can copy stuff from it that I'm gonna need. Okay, so now we have an actual renderer, and we have a swap chain. Now what we're gonna need is a window renderer that would take that swap chain and render together. Yeah. So the idea is that you're gonna have a window renderer now. So you're gonna have a window renderer, and like you could have other kinds of renderers, like offline renderer or whatever. Or an image renderer, whatever. So let's just try this out and see. So window renderer attached to module. I'm not sure yet. So what I'm thinking about that we're gonna have is public struct window renderer. We're gonna have a renderer and an arc window. In fact, I can copy some code from here, yeah. So of course I'm gonna need the frame here. This is where I'm gonna need the frame. And what else? Not here. And here I'm gonna need the pipeline layout and so on. I'm confused. What the heck? Yeah, remove this for now. I don't care about this. I don't care about this. I don't care about this. Okay, cool. So we need the frame and we need this stuff right here, I think. Well, what? I'm confused. No, I need this stuff. No? Bro, what the? Which one is it? This one. Why we have a render target here though? Oh yeah, because I already have this on. I see. Alright, so what I'm gonna need is all of these stuff. Except for the render target. So where I'm gonna put it? Not sure, maybe here. Well, actually, let's just put it, I guess, here. So you have an allocator, you have a swap chain, you have a rendering context, you have a renderer, and an arc window. Cool. Though you're not gonna have a pipeline and a pipeline layout. You're gonna have a command pool. You're gonna have frames, frame index, in-flight frame count. Allocator, no, you're not gonna need that here. So these are all the things you're gonna need. Yeah, I think so. Let's actually put these here really. And let's go. That's what I'm talking about. Now let's actually implement this thing. So implement window renderer. Whoops. And pubfn. Well, let's go step by step, please. Pubfn new. You're gonna need the context. It's gonna be an arc rendering context. And you're gonna need a window. Arc window. You need in-flight frame count. Right. So you need the context, you need the window, and how much in-flight frames you want. Perfect. Now what's next? Let's see. Of course we don't want the shaders. I'm confused. Which one which? Yeah, I'll remove this guy. Okay, cool. So let's see what we have here. We don't want allocator. We don't want the shaders. We want the swap chain. So let's copy these lines right here. We're making a swap chain. Can I use the operator here? Makes sense. Let's actually say result self. And no, let's use anyhow result. Cool. And now what's next? We don't need any of this stuff. No, no, no. Oh, we're creating command pool here. We're gonna need that. Let's just say okay real quick, please. Self. Call to an unsafe function makes sense. Okay, so we created our command pool. Well, actually, let's put this here inside. Cool. So command pool, we're gonna create our command buffers, our frames. Yeah. And maybe that's it. Is there anything else that we're gonna need? Frame index is of course 0. And yeah, we gotta create a renderer too. That's the last thing that we're gonna need there. Let render is equal to render.new. That's of course not what's supposed to have here. We're supposed to give it resolution and then a format. Now for the format, I think that could be given as an argument. I feel like, yeah, I guess, maybe. And there you go. So now we have all of that stuff. Perfect. And you're gonna have a resize function, of course. Self. The AI just gave up and told me to say to do. Self.swapchain.resize, yeah. And well, actually not that. Here we're making the swap chain dirty, yeah. So we're just gonna say, I mean, yeah, pretty much just say this. Swap chain is dirty. Though we gotta, interesting. Should I resize the render immediately? I don't think that's what I need or what I want. Hard question. We're gonna see. So like we need somehow, actually no. We're gonna do that when we trying to resize the swap chain itself. Yeah, before we resize the swap chain. Yeah, that makes total sense. And now we're gonna need, I guess, a pubfn render function. Mutable self or just self, not sure there. And of course it's gonna have a result, pretty much. Perfect. Now let's see what we're gonna do here. So we're gonna have all this craziness up until I mean, honestly, I think I'm just gonna copy this whole render function and then edit it however I want. Yeah, for real. Let's do that. Perfect. And let's see what we got here. So I'm not gonna need the renderable image state here. Let's import this stuff. And we don't have a render target here. In fact, this whole thing right here is part of the render itself, basically. So this part right here is the renderer. Whoops. Oh my god, I hate this. So render self dot render dot render, and we're gonna give it the command buffer. And what else it needs? It needs a clear color. For now, let's just hard code it. Or actually, we should really get the clear color maybe from the user. I mean, he's the one who knows the format. That's true. So, though it doesn't have to be, I don't think we want clear. Yeah, that's actually good. Yeah, cool. And of course we want to store that. Where to store that? I don't know, whatever. And then we want to add it to the struct. And provide the argument. Okay. We're gonna say self.clearColor. And this, okay, cool. Perfect. Now we want to transition the swap chain. Now this render function, I think it's probably, I mean, no need, I guess. Anyways, so transition the swap chain image to transfer destination layout. Cool. And here the render target would be well, render target dot handle. Oh, transition the render image to transfer source layout. But we need the old renderable image state. I see. What we could do is the render target dot layout. Yeah, and we just gotta make sure in the renderer when we actually do those layout states, I mean, they're supposed to actually be done in the transition image layout itself, but for now let's just hard code them. Let's see. Oh boy, what the freak? What I was doing. Now I'm very confused. Let's go to the renders. Yeah, there you go. So what I'm talking about, for now at least, is I think this one, probably. Yeah, this one. So let state is equal to this. And let's just real quick just say self dot what I'm doing in render target dot layout is equal to this state. In fact, let's do that after the transition directly. And this is supposed to be inside of this transition image layout, but right now I don't want to change it just yet. For now, we're just hard coding it. So yeah, what else? Did I actually change anything here by accident? No, I didn't. Nice. So transition the swap chain image to transfer destination layout and transition. Perfect. Copy the render target image to the swap chain image. Copy the render target image. Not anymore. Well, actually, yeah. Render target dot handle. Okay, and here dot extend. Use of indeclared extend 3D. Transition the swap chain image to present layout and document buffer. Oh, is this really it? Like for real? Suspicious. I mean, I guess there's one way to find out. Is to try. Oh boy. Okay, so let's go back to the app, I think, right? Or the engine, yeah, the engine. So here, now, instead of having render here, we actually should have window render. Is it public or not yet? It is public. But it shouldn't be inside of here. It should be inside of the engine, at least for now. Oopsies. I probably, well, yeah, okay. Import, perfect. Let's see, did we break something here? Oh. It's actually pretty simple, maybe. Is it the only one that we actually need here to access? Oh no, the swap chain is also private. No, that's not gonna freaking work. Please take it back. What the heck did I just do? Hey, that's strange. Window render to the renderer, refactor. Is everything okay now? But it wouldn't be accessible anymore here. Right? And somehow it's still accessible. I don't know. That's strange. But either way. So we no longer want a render.new. We want a window renderer. New. And here the context dot clone and the window dot clone. And finally, what else? I think, yeah, in flight frames count, let's just go with 2. And the format and the clear color. So the format, let's go with our what is it called? VK format. S float. Well, R16. S float, yeah, there you go. Comma, and the clear color value. I have no clue if this would work. If it works, I'm crazy. Cannot use the operator. Fine, just say the in wrap please for now. And yeah, what else we have to change here? We no longer need that, yeah. And oh, I do remember that's something I didn't do. And of course, the same exact thing here. How are we gonna do this? Let's just copy this guy. Let's do that. And self.rendering context. Okay. Oh boy, that's a huge refactor right there. Hopefully it would work. Because if it doesn't, oh boy. I'm not ready for a long debugging session. That would be crazy. Alright. It seems no errors right now here. That's great. Now, the thing that I forgot to do is in the window renderer. Field command pool and window are never read. What? Impossible. What do you mean never read? Really? So how the heck do you... Oh. Oh, but it's not being... Ah, I see. It's not being dropped properly. That's why. So for that, we're just gonna copy the one that is in here. I'm just gonna drop this whole crap. Well, not render, window render. No field allocator in type. Yeah, we don't need this. We don't need these either. And yeah, perfect. The other thing that I want to make sure is that we're dropping the render stuff. Yeah, we are. Cool. Okay, so apparently... Oh, yeah, we're still not calling the resize function, I forgot. Let's see where we're actually resizing the... Well, not here, in the window renderer. Where we're resizing the swap chain. After we resize the swap chain, we should also resize the renderer, basically. So... Well, after we get the renderer... it should be good here. And where we should not... Well, here, yeah. There you go. That's what I'm talking about, dude. I think that's it. Field window is never read. Right. Yep. So let's try this and find out if this would work or not. I have no clue. Really? I mean, it does look like it worked. No way. That whole refactoring, it's still working? Bro. This thing right here, what's up? Vk destroy image. By Vk command buffer. Now, the only thing that I'm not sure about is that I'm not sure if we need to have a render, like a separate render target for every single in-flight frame, or what exactly, or if sharing one is enough. I don't think sharing one is enough, and maybe that's why we have those errors. So what we should probably have is render targets vector, right? Not just one render target, too simply. And then where's the render target here? There you go. So we're gonna say render targets instead. Oh well, hold on. Well, let's call it buffering. That's a good name, I think. And I'm gonna say 0 buffering. There you go. Okay. Well, here we could just use the resolution. Actually, why the heck we need it here? What? Why create graphics pipeline needs the extent? Oh, for that stupid viewport thing. But we are actually updating it though every frame. It's not really needed. So what we could do, I think, or you know what? For now at least, just do it. I don't want to deal with that crap. Just do it. Though it's probably unneeded since our viewport is dynamic. Okay, cool. Now for the resizing, we gotta do it for all of them now. Cool. And well, for the render, it's interesting. You gotta tell me which render target you're talking about. Exactly. At least that's the idea. And then we're gonna say render target is equal to that. Hmm. Oh, I see. So you gotta do the same thing here. But now we also need the render target index here. Okay. There you go. I believe that's it. Destruction, we gotta also handle that. And I think we're good. Oh boy. Of a mutable binding, okay. Does that help? And yeah, cool. Now let's go to the window renderer. And by the way, how much, hold on, where I'm creating the renderer again? Yeah, there you go. Now I need to add in the how much buffering we're gonna do, which is too simply the swap chain dot, well, not desired image counts, but the actual images count. There you go. Though this function takes 4 arguments, but 3 arguments were sublocked. Alright, the other thing though is that when the swap chain is resized, it may actually change but let's not think about that right now. I think it should probably be fine for now. This function takes 3 arguments. The render target index, which we're gonna use here, the swap chain index. Image index, right? Or no? I mean either the, not really, hold on. No, what I'm doing. No. No, it should be the frames, my bad. Should be the frames, I think. Yeah, let's go with the frame index really. So self.frame index, and with that out of the way, it's not really the swap chain images length. No, it's really just the, what did we call it? In-flight frames count, exactly. And oh boy. Let render target is equal to more polygon handlers for the god of polygon lords. Veronic Lynch, welcome to the live stream. Self.render targets. Well, self.frame index, yeah. And now we could just remove these. Remove these. It's not polygons here. Right now we're going crazy with render targets. Field window is never read. I think that's it. Let's see if that fixes that error. No, we still have that error apparently. Ba ba ba. Destroy image that is currently in use by Wiki command buffer. Must have completed execution. Vacate destroy image. Hold on. I have a little idea we could do here, I think. And I forgot completely about it, which is break. So the moment we're gonna have an error, it will break. And hopefully I can get the call stack now. Oh boy. In the resize function of the render, apparently, when I'm doing the render target stuff. Ooh. Huh? In here. Oh. How that works with the swap chain, but it doesn't like it with the... So I think basically what's happening here... Yeah, I see. I see. But for now, to fix it, I think we could probably just say the self.device. Not the best, but I think it would work. Right, device.device wait idle. So basically here when we're resizing all the images, not just the image that is inside of the current frame index. Now I could fix that, but let's see just if this would work. But like, in fact, if that, you know, didn't work well with the render, then it shouldn't work either with the swap chain too. But there you go, it works fine actually right now, which is great. Perfect. Oopsies. Okay. Yikes. In create image, render, right? Yeah. Ba. In here. Resize. Oh boy. Well, I think we could just do this then. Well, actually we still need that there. Well, we also need it here basically. There you go. So right now we have decoupled the render from the actual swap chain. Like basically we could use our render to, let's say, render into an image. Right now I could go ahead and create another class called, let's say, instead of window render, image renderer. Then you would have the setup to just render for an image, which is pretty cool. Oh boy. Should we try to do that? For that, we're gonna need the command pool again. We're gonna need the command buffers, yeah, and we're gonna need... but we're not gonna need the synchronization. It's gonna be way easier. So yeah. I mean, I think we could try to do it, yeah. So I can show you why this is useful. Like, this would like be, actually instead of image render, maybe you could say offline. No. What do they call it usually in other libraries? Do they call it off-screen render? Or what? I think so. Let's call it offline render, fine. Or image. Oh boy. Let's call it image render. Oopsies, cancel. I don't want to rename, like, hold on. Let's refactor this to image render. Right. So the gist of this is that you're gonna have a public struct image render, right? And this time you're gonna have a context, yeah, and you're gonna have a render. You're not gonna need a pipeline or any of that crap, though. You're gonna need a command pool and a command buffer and so on. Where is it? You're not gonna need the frames. Well, I mean, no, you're only gonna need a command pool and a command buffer. So you could actually go ahead and submit your thing. So a command pool and the command buffer. You're also gonna need the clear color value. And that's basically it. Let's use anyhow result. So here we're creating a command pool as always. And we don't even need this flag since we're gonna have one command pool. So no need. We're just gonna reset the whole command pool because we're gonna have one command buffer too simply. And what else? And then pubfn render, I think. And so the point is, well, let's see. So we don't need any of that crap. No. We're gonna make sure to reset the command buffer, yeah. But like, we're just gonna reset the whole command pool. Well, in safe first of all. Oops. In safe, self.reset command, well, context .reset command pool. Well, .device.reset command pool. I'm not sure what this release resources is for. Probably not a good idea. Let's just say empty. Let's say okay here. Alright, so after resetting our command pool, we're gonna begin recording. So begin command buffer. And yeah, self.command buffer too simply. And here again, self.command buffer. Here frame index 0, because there's only one render target really. Oh no, not renderer here though, dude. So we're gonna have render here, but like, why the heck? Oh, I see. Or the other. Yeah, so you're gonna have clear color, yeah, and also format and resolution. You're gonna pass in resolution here and format here, I think. Buffering, we're just gonna go with 1. We don't need buffering here since we don't have synchronization to worry about. And in the command buffer, really? Yeah, cool. And then we have to submit. No need for any transitions for now. We're just gonna say queue submit. Self.command buffer. And we don't need any wait semaphores. Yeah, we don't need any wait semaphores. Nor do we need any signal semaphores. But no, though if we don't have any of these, then we do need the fence though. I see. So we do need, after all, at least a semaphore and a fence. But I think to keep it simple, I'm just gonna go with the fence only. To keep it very simple. But yeah, maybe we could make use of a semaphore too. But for now, let's keep it very simple. Vacay fence. I'm just proving a point here. Now, we don't want to signal any semaphores, but we do want to signal a fence. How do I signal fence? Oh, I see. So we don't want these. And self.fence. Pretty much. And then, well, actually we need to also reset the fence. Well, wait for fences. Well, self.device.context .device.wait for fences, and then we gotta reset it, of course, and then but no, we don't need the signal bit, I think. Yeah, we don't need the signal bit. And here we're only gonna reset the, well, in fact, we're gonna do this stuff here after the fact. So this would basically wait the whole program, like hold the, stop the thread until the image gets rendered to. And then like you could have like an fn save function. Oh boy, you do gonna need, like if you want to save it into disk, you do gonna need another image that you're gonna need to copy. I see, because the thing is, the image of the render target of the renderer, you can't use it directly, you know, because it's optimal tiling, right? So you cannot read it from the CPU. So you do gonna need another image in here that is gonna need a tiling that is linear, and then you gotta copy that image over. Yeah, that's pretty cool, huh? That is very freaking interesting. So we have image here, and we have to basically create it. Well, not that way. And so I'm gonna need the allocator too, apparently now. Where's the allocator, bro? What? We could use a render allocator, dude. Yeah, that's true. So what we're gonna do, though, I gotta make sure. Yeah, that would work. So self.render, well, render.allocator, not clone, just mutable, yeah. And of course mutable, and resolution. Oh, you gotta need a name. And what else? Some image attributes, I think. Is that correct? Yeah. Some image attributes. So this is the most important part. It should not be false, it should be true. Otherwise you cannot read it back. So this is gonna be like the download image, essentially. Usage, it's only gonna be a transfer DST, pretty much. And for the memory location, this should be available to the CPU or readable from the CPU. So memory locations, GPU to CPU, that's exactly what I will need. And what else? There's no default values, dude, here. Allocation scheme, probably managed. Let's see. GPU allocator managed, I don't care. And so these are the most important parts here. Linear equal true. So GPU to CPU and transfer DSC. All these for the download image here. And then, so interesting. Yeah, then we're gonna copy the image over. So we're gonna transition the render image to that, to SRC. But how I'm gonna do that? Dude. Well, which image? Yeah, that image, okay. To transfer, actually destination layout. To transfer DST. Is that it? What is the third argument here? Image old state. Yeah, image layout state. Okay, cool. So image layout state, well, whoops. Can't believe this sucks so bad. Access mask. Access flags to empty. Whoops. That's the old state. The new state. Transfer DST optimal. Transfer right. Transfer key family ignored. Perfect. Then after that, we're also going to transition the render or the render target image to transfer SRC layout. Exactly. And yeah, I actually realized what to do there, which is nice. Perfect. Cool. Now I could actually do the copy operation. But it completely effed up this part. SRC extent. There you go. But hold on a second, how the heck can I actually read an image? Like, I guess I map it, but I only can map buffers though, I think. Actually, true. Yikes, 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 yikes. Hold on. Self.context. Let me see what we have here to map. Device.map. Well, we can actually map the memory of the image. I do not know. We'll see. We'll see how it goes, I guess. So actually probably self.image.allocation. Let's see if we could actually map it or whatever. Oh, I could get the mapped slice. Nice. So, okay, great. So here we're ending the command buffer, then we saying q submit. And so after waiting for all the fence and stuff like that, then we could actually let data is equal to self.image. Hopefully this would work. Let's see, self.image.allocation. No, mapped slice. In wrap. Cannot move. Oh, as ref. And here we're gonna need now the image crate. Come on. Want to make 250% transparent plane, but the front plane hides rear plane. I hope this works. Otherwise, we're gonna create a buffer instead, I think, and then we're gonna use another command called copy. Copy image to buffer or something like that. Now save using image crate. I guess there's one way to find out once again, is to try. Yikes. Actually, let me look into the image crate here real quick. I believe there is a code snippet somewhere here to save a raw thing. Yeah, there you go. Image save buffer. Yep. So, image save buffer. There you go. Perfect. And if everything goes into plan, then we're good. All right, time to find out. Let's see. So let's go to our app and let's just create a little render real quick. Well, not in the app though, in the engine, yeah. And let's just quickly say let image render rendering context. I need the rendering context first, of course. Cool. Now we created an image render. Now let's use it to render. Okay, time for the to see if this actually works or not. Oh boy. If it doesn't work, then we just gotta use a buffer instead of image. But I hope it would work already. Just too tired. Let's see. And oh boy, crash. Oh. Why? Why it got destroyed? What the heck? Somehow the rendering context got dropped. What the freak? This is very strange, but I don't have the time right now to think what the heck happened there. So what I'm gonna do real quick is to just store the image render here real quick. Put it here just so we can stay alive. I think that's probably the problem right now. And oh boy, what the heck? I don't get this, honestly. That's strange. Well, let me remove this break from here and see what's up. Didn't work. I'm probably gonna need yeah, I'm probably gonna need the copy to buffer thing. But you know what? I mean, I guess, yeah, okay, maybe. Oh my god. Alright. Man, I'm too lazy to do that at this point. But I think you got the point. Should work. But yeah, I think for now, what I'm gonna do is see what we got. Oh boy, that's a lot of changes right there. So gonna revert this change right here. And revert this change, revert this change, this change, and yeah, we're good. And revert this change, delete this, add the window renderer to the files that we want, and let's go. So this is basically decouple the is it just that though? Yeah, decouple the renderer from the windows, or from the swap chain. Yeah. So let's go ahead, commit. Perfect. And yeah, there we go. So that was a big architectural change of the engine. It's way more flexible right now. But yeah, that's crazy. How much time have passed? 4 hours. Oh boy, I'm already quite tired at this point. Is there any questions before we end the stream? Is there any questions? Right now I think I'm gonna publish this to GitHub, and yeah, so let's see. So Vulkan 1.3 rendering, dynamic rendering, Vulkan 1.3 dynamic rendering. I think that's all using Rust programming language. Or you know what? No need to mention that stuff. Just say like modern Vulkan basically. With modern Vulkan API, graphics API. Using Rust programming language. Just a small description. Also, you know what? I'm gonna fill in the description later, fine. Just share this thing, please. successfully shared. Perfect. And there you go, dude. We're live on GitHub. That's cool. Let's actually add the license. Create new file. Name your file. License.m. Well, just license. Choose a license template. Okay. Code.mit license. Whatever. Review and submit. Commit changes. And there we go. So I guess that was it for this stream. Next stream we're gonna try to do some more. Probably we're gonna go with the trying to make a cube and so on. But yeah, we'll see about it. We'll see what we're gonna do next time. So that was it, guys, for the stream. If, by the way, if you can check this out, see if it works for you first of all. And second, if you find any bugs or you want to add any features, please make sure to either file an issue or pull requests. You're welcome. And we're gonna like revise it in next streams. So yeah, that was it, guys, for this stream. Thank you all for coming in. Thank you for Theo Paris, Marinite, Woji, Girin, Loop Luminary, Baroni, Lynch, and yeah, that was it, guys, for the stream, and see you later. Goodbye, everyone.